Assalamu alaikum. Welcome everyone to another video regarding ETAP software. And today we are going to uh, show you how ETAP can help us analyzing arc flash and help us to fight against arc flashes in the power system. So before going into the software part or the simulation part, just I want to give you a quick idea about the arc flash itself. Uh, we know that if there is a gap between two current carrying conductors, and we know that even though there is a gap and there is nothing in between, but there is air itself, and air has different particles, and because of that, and most of the time and sometimes, it creates uh, an arc between the conductors. It may occur during line-to-line fault or single line to ground fault, or at the time of, opening the circuit breakers or opening the bus bar ties. Okay. So in these type of situations, or maybe at the time of uh, occurrence of any other type of fault, this type of arc flashes occur. Okay, so whenever there is an arc flash, the most important thing is that it creates a fire with a very high temperature. So you can see 35,000 degree Fahrenheit, and along with the fire, it generates some pressure waves and molten metals. So it means along with the arc flash, it creates after the arc flash, it creates most of the time a kind of arc blast. So which is of course understandable, that very much threatening for the life of the people around, and also damaging for the equipments. So that's why arc managing arc flash well in the power system is very important. And occurrence of arc flashes are very common in the power system. So that's why we need to take necessary actions about the arc flashes. How can we take actions? Actually, we can, if we can analyze the arc flash before, ahead of time. In that case, we will be able to know that if this is the location of the place where arc flash may occur. So what is the area? So that means what is the distance which is safe for a person or a human to work. Okay, so we call it arc flash boundary, AFB in short. Okay, remember the term, short form AFB. So arc flash boundary is the place like where a person with a proper dress up, we call that dress up PPE. The full meaning is personal protective equipment. So with a proper PPE, someone can work or someone can stand and so on. So it is very important for us to know that at what place or at which place of the power system, what is the value of AFB? Maybe in meter, maybe in feet. In most of the time, we can get it in feet. Okay, so the distance, most important that it is a distance. So this arc flash boundary is very important. Then, like after a certain distance, we can have a limited space, and this limited approach boundary is the place where also someone can enter and work, but with a proper protocol, with a proper, procedure, following a proper procedure, and with the permission of course, experienced engineers and so on. But after this zone, which is known as restricted space or restricted zone, no one is allowed to enter and work. So actually, this is how ETAP can help us. So how ETAP can help us, actually, whenever we do an analysis in ETAP, arc flash analysis, it provides us the value of this arc flash boundary. Not only that, it can give us the proper guidance of what type of PPE we should wear. And also, it provides us what is the energy, okay, arc flash energy. So this particular arc flash produces. So if the value of energy is high, so this distance arc flash boundary should be high also. So that means you cannot enter, you cannot go closer to the origin of the arc flash boundary. So that's why using ETAP to generate the arc flash report or arc flash analysis, is very, very important and crucial. So, and here we can see that there are different PP levels. So these are all PPE levels. So based on the necessity or the arc flash strength, so you can decide which PP is suitable for you. So as I have already mentioned that, the PP category, it depends upon the energy it generated by arc flash. Okay, so you can see like if the value of the energy generated is increasing, so like from 4 to 8, 8 to 25, the distance or the arc flash boundary also increasing. Okay, I think there is a typo here. It shouldn't be 5 feet. Sorry, yeah, this is 5 feet and this is 3 feet. This is 19 inches. So, and more, boundary, the boundary increases. Also, the PP category increases along with it. So, this is the general idea regarding the arc flash analysis and arc flash itself. So now let us go to the ETAP software, and we'll try to see that how we can generate the arc flash report or the arc flash analysis using ETAP. So this is the power system model we built before in one of our previous videos and previous experiments, where we used 2 generators and 2 loads along with this power system model. You can see the multiple transformers are there, 3 transformers and 1 transmission line. And this is how we build the power system. So before applying the arc flash, let us just double check that the load flow works properly or not, to make sure that everything is fine. Yeah, the load flow is running well. So that means it is fine. So before applying the arc flash, actually, this is the button, or this is the option to apply the arc flash. You can see this is arc flash. By the way, before applying that, we need to modify the power system model a little bit. So what we'll do, we will add one more branch with this particular load 11 kV, because we'll apply the arc flash in the distribution side along with a low voltage circuit breaker. So what we can do that this is 11 kV. So we step down the voltage from 11 kV to maybe 400 volt or something. Okay, go to the rating. So primary is 11 kV, which is already known by us. Secondary, let us make it 0.45. So that means 450 volt. Okay, MVA rating, it could be 100. And go to the impedance. So the currents are all calculated automatically, like 100. Let's make it 100. And impedance, just select any typical data. And this is the rating of the transformer. Okay, you don't need to do anything else. Click OK. So just connect this one with the bus bar. Bring a second bus bar with it. And as you know that if you just connect this one, it will become 0.45 kV automatically. Okay. So after that, you need a low voltage circuit breaker. Here it is. Bring it. So before connecting, let's enter into and give some ratings. For example, you need to provide, you need to particularly mention, just have a look, what type of circuit breaker and trip device you want to use. So there is a library here. Okay. So you enter into library. And whenever you enter into library, you will see there are different type of type of circuit breakers. You see molded case circuit breaker and power circuit breaker, insulator circuit breaker. Let's select the molded case, no problem. We call it MC circuit breaker or MCB, MCCB. I think this is very known to us. Manufacturer, you can see ABB, which is very known, Allen Bradley, the Challenger. We can use Cutler hammer, maybe. Okay, let's select the Cutler hammer. And now, after we select the Cutler hammer, we need to apply the proper voltage. You see, inside Cutler hammer circuit breaker, we have different models. Okay, so we need to select the correct model. Which is the correct model? Maybe you can remember this circuit breaker. We will connect with a bus which is 0.45 volt, right? So maximum kV should be around 0.45. Okay, so let us go down and see if there is any value, yeah, which is close to 0.45. Here it is. So you can see this is 0.48, but we will use 3-pole because this is a 3-pole. Like we will select 3-pole circuit breaker for 0.48. Okay, so select this one and click OK. Okay, so you can see this circuit breaker has been selected properly. So now if you go to the trip device, now you will see the same Cutler hammer trip device, a circuit breaker. It is shown over here. Okay, so now this is all ready. You can click OK. Now you bring one more bus, sorry, here. Okay, so once you connect this one and you connect this one, the next bus will become 0.45 kV also, because they are the same voltage level. So finally, to complete the circuit, you bring another load, static load. So put it here. Okay, enter into. We should make sure that the current ampere shouldn't be very high. Okay, so we will select a small, we'll give a small load. So what will be the kilovolt? 0.45, right? And MVA rating, let's select 0.3, and megawatt maybe 0.03. Okay, sorry, 0.03. Okay, so if you select these values, your ampere rating is within a reasonable range, which is 38 amp, which is fine for us. Okay, so and the other things we don't need to change any other things. Okay, you can select different cables and so on, which is not required at this moment to run the arc flash analysis. Select OK and just connect this one. Okay, so save the project. And first of all, run the load flow to make sure that the new connection is okay. Yeah, it is okay. Okay, no problem over here. So now we will go for arc flash analysis. So this is the arc flash. Select the arc flash button. Okay, and there is 2 buttons to apply the arc flash. The first one, the top one, if you want to use this button to apply the arc flash, you need to make one bus faulty. But if you use the second one, this is fault insertion. So it will apply the fault automatically, and then it will find the arc flash automatically. So we can use the second one. Okay, then I will show you the first one also, no problem. So once you click this, so it brings a kind of flash symbol for you, sorry, arc symbol for you. So this is black color, but wherever you want to apply the fault, whenever it take you to that particular bus, it becomes red, that bus, and this arc becomes yellow. So let us apply the fault over here. Okay, so this bus number 15, we bring it and just click. So whenever I clicked, it will take some time, and now you can see. Okay, so this is the values we are looking for. Just have a look, and it is clearly showing you with an animation that this circuit breaker needs to be tripped. Okay, and what is the time to clear this fault? This FCT, if I zoom in a little bit to show you the values clearly. Okay, so you can see the values. So FCT is the fault clearing time. So the circuit breaker rating and the time set inside it, based on that, it will take only 0.014 second to clear the fault. And the current at the time of fault clearing time is 335 kiloampere, 0.93 kiloampere. So the fault current is very high. Okay. And now have a look on the next values. It is showing this is level 3, level C. It is actually showing the level of arc flash. we divided it into different level, and also it categorized the PP level. Okay. AFB is the arc flash boundary. So this 3.1 feet is the arc flash boundary. You cannot enter within this restricted zone. And IE is the incident energy. So what is the energy? This is 5.211 calorie per centimeter square. This is the unit for the incident energy at 18. At 18, I think this centimeter or feet. Like we can know it more in more detail. If you want to know it in more detail, we can go to report manager, click on the report manager, and either we can find the complete one, or maybe we need the summary. Okay, just click on the summary, arc flash summary, incident energy summary. Okay, PDF. If you click OK, it will give you a PDF output of the arc flash automatically. Okay, so you can see this is the bus incident energy. Okay, so let me zoom in a little bit more so that you can see it. Okay, so this is the bus incident energy summary. So arc flash analysis results. So what is the arc flash boundary? This is in feet. Energy level, level C. Incident energy is calorie per centimeter square. And fault clearing time, it clears the fault in this amount of cycle. So less than 1 cycle, which is which is very fast. Okay, and also over here you can find some more detail. Okay, so you can generate the report as you need. Okay, not only that, there is another important idea you need to understand here, is that as because we are in need of running this type of analysis before we energize the power system. So this is the part of planning phase. So that means whenever you build a power system and you need to energize the power system, before giving, before you allow the power to flow, you run this type of analysis through ETAP, and you apply the arc flash in different locations, and you know that what is the values of arc flash boundary and all the details at different locations. Now, if you can print a label for it, okay, so you can, if you can print a label or a sticker of it, then you can easily paste it on that region or that area, so that the people, the technician or the engineer who work over there, they can be careful ahead of time, and they can avoid any type of damages. Because of that reason, like there is an option to print the label of the arc flash, so which is a very like beneficial feature of the ETAP software. Just enter into this arc flash analyzer, and you select the bus. This is the bus where you applied. Okay, you click on this incident energy. Okay, so it will give you the bus number 15 where we applied the fault. Okay, so then if you click on this standard label, so there are different type of patterns, different type of patterns, like to create the label for you. For example, let us just check the first one, then I will show you one more. Okay, select PDF, click OK. It will generate one label or a sticker for you. You see, this is, so it shows the danger and arc flash and shock hazard, what is the boundary and incident energy and all the things. Okay, so this is one style of the report. There is another style of report or the label. So sorry, this is not the report, this is the label. So maybe let us check one from the bottom. Okay, let's check this one. Is a bigger size. Select the PDF, click OK. So there are many different styles. Whatever you like, you can print that one. This is the old one. This is the new one. You see, this is with big warning symbol, and it gives you the detail. Okay. So by printing this type of labels, or maybe making it a sticker, you can easily make sure that your area is safe from the arc flash. Okay. I can show you one more thing. There is a data sheet here. Okay, so even you can, I think you can print the data sheet. As far as I know, you filter reports. Okay, so there is a way to print the data sheet also. But this option is not working right now. However, uh, because we already know how to print the detailed report, so there is no need to print the data sheet. It is the same thing actually. However, so from here we showed you that how can we generate the report. This is the report, like our flash report, and we showed you how to generate the label. So there are different styles of labels. This is one style, this is another style. And also before we finish the video, I want to show you that there are different options you can change and modify. For example, if you enter into this edit study case, so this tab will open for you, and where you can see this arc flash study data. Okay, study case. So all the detailed information, where you applied the fault, and you can change different things and the method you used. You see this, the arc flash method, it is following the IEEE standard 2002 model. So there is another version 2018 model. You can use that one. And like what type of fault you applied. You applied three-phase fault, symmetrical, half cycle. This is the bus fault current, and clearing time. There are some standards selected. You can change and modify them. Okay, so the parameters you can see, like the working distance parameters. So there are different standard also present. PP standard, so you can change the PP standard based on it. Okay, and shock risk assessment and different. Okay, so uh, like if you are more interested on this topic, you can go deep into it and see what different features give you. Okay, so but as a beginner, to know about the arc flash analysis and to know how to run the analysis and get benefit from it, I think we have covered the necessary things in this video. So thank you very much for listening, and I hope that uh, it is helpful for you. Thank you very much.